Prime numbers means numbers which are not divisible by any other number except one and the same number. Set of all natural numbers less than 0 is not possible. It is again an empty set or a null set. A set containing finite number of elements is called a finite set, whereas if a set containing infinite number of elements, then it is called as an infinite set. Number of elements in both the sets are equal means then the two sets are said to be equivalent set. That is, if n of a is equal to n of b. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take very important and easiest chapter, that is sets, relations and functions. So this is very simple and easiest chapter. Now, before going to exact the chapter, let us know regarding the weightage of this chapter for the final examination. So, the total marks in this chapter is 15 marks. So, this will fetch us around 15 marks and 1 mark, 1 question. You will get one mark question, and a short answer 2 marks questions will be 1 question will be there for 2 marks, and long answer that is 3 marker question, 1 question for 3 marks, and short essay type question, that is for 4 marks is 1 question, and long essay type question for 5 marks. So, you will have 1 mark question, 2 marks, 3 marks, 4 marks and 5 marks. So, totally 5 plus 4, 9, 9 plus 1, 10 plus 5, 15 marks you will get from this. So, in all parts, in part 1, part A, B, C, D, E, you will have 1 question. So, totally this will carries 15 marks. Very easiest concept. Now, let us come to the first. Let us discuss regarding the sets first. Now, sets, relations and function. The first part is the sets, then the relation, then third part is the function. Now, let us come to the sets first. The first part is set. You might have been studied in your previous class regarding the definition of a set and the representation of a set in different forms, that is construction of a set in different forms, and the operations on sets. So, the same thing we are going to study in these sets also. Now, let us come to the definition. What is the definition? A set is nothing but a collection of well-defined objects. The collection of well-defined object is called a set. For example, set of all second PUC students in our college, or set of all first PUC students, first PUC science students in our college, or set of all first PUC commerce students in our college will form a set. That is, the collection of well-defined object is called a set. So, a set is a well-defined collection of distinct objects. Each members is called the elements of the set, and usually a sets are represented by the capital letters. Let us consider A. A is equal to A, E, I, O, U. These are nothing but the vowels in English alphabet. A, E, I, O, U are the vowels. This will form a set. So, here A, E, I, O, U are called as the elements of the set, whereas the capital letter will represent a set. So, another set, let us consider B is equal to 1, 2, 3, 4. So, B is a set, the set of natural numbers up to 4. B is equal to 1, 2, 3, 4 is a set. Here 1, 2, 3, 4 are called the elements of the set. That means here we can write 1 belongs to the set B. Similarly, 2 belongs to the set B. This symbol represents belongs to. Now, the set of even natural numbers. Even natural number is an example for a set of even natural number. That is, set of even natural numbers can be written as n is equal to even natural numbers 2, 4, 6, 8, etc. This is an example for a set. Now, set of days in a week, set of days. So, the set of all the days, that is Sunday, Monday, Tuesday, Wednesday, all comes under this set. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Right, the set of all the days, set of days in a week. Similarly, the set of vowels in an English alphabet, that is nothing but A, E, I, O, U. These are all examples for the set. So, that means in total, a set is nothing but a collection, the collection of well-defined objects. The collection of well-defined objects. Whatever may be the objects, may be the things, numbers, elements whatever may be, just it should be a definite object, collection of definite distinct objects. Now next, how to represent this set? So the representation of a set or construction of a set, so that is nothing but methods of describing the set. A set can be described or constructed in two methods. The first method is called the roster form, or it is also called as the tabular form. A set can be represented in two forms. The first form is called the roster form or tabular form, and the second one is called as the set builder form, or it is also called as the rule form. So first one is a roster or tabular form, and the second one is called the set builder form, or it is also called as the rule form. These are the two methods for construction of sets. Now let us come to the first one. What is the roster form? In roster form, all the elements are listed separately by the commas and are enclosed between the square within the brackets. That is, in the roster form, all the elements of the set are listed and they are separated by the commas and are enclosed within the brackets. Let us consider the set of all even numbers between 0 to 10. Set of all even numbers between 0 to 10 is nothing but 2, 4, 6, 8 is an example for a set in the form of in the roster method. So here all the even numbers lies between 0 to 10 is A is equal to a set 2, 4, 6, 8. This type of representing a set is called a representation or construction of a set by roster method. That is, here the elements are listed and they are separated by the commas and are enclosed between the two flower brackets. Now one more example. Suppose if you take b is equal to 1, 3, 5, 7 odd numbers, that is odd numbers up to 10. So the odd numbers between 1 to 10 is given by 1, 3, 5, 7. This is also an example for a set in the form of a roster form. Okay. Now let us come to the second method, that is called a set builder form. So in this method, all the elements of a set possess a single common property which is not possessed by any other element outside the set. That means in set builder form, the elements of the set are depends upon the particular statement. The elements of the sets are arranged according to the given statement or according to the given definition. Here the elements are listed or possess a single common property. That means the elements of the set are listed according to a statement or the given property. So let us consider if A is equal to 1, 2, 3, 4, 5, then the set builder form is represented by a set A is equal to X such that X belongs to natural numbers and less than 6. This is the statement. According to the statement, the elements are arranged. So here in a set builder form, the elements are arranged according to a given statement. Here what is the statement? A is equal to a set A is equal to X such that X belongs to a natural number and which is less than 6. So all natural numbers less than 6 is nothing but 1, 2, 3, 4, 5. This is an example for a set builder method. Okay. Now let us come to the problems. Let us come to this exercise problems. Represent the following sets in both roster form as well as in the rule form, set builder form. Now first one, the set of all multiples of 3, set of all elements of the form multiples of 3. So let us write A is equal to set of all multiples of 3 are nothing but A is equal to 3, 6, 9, 12, etc. This is the set A, that is in roster form. In roster form, the elements are 3, 6, 9, 12, etc. Whereas in set builder form, that is in rule form, A is equal to X such that X belongs to a natural number and X is equal to 3n, where n is any natural number. So X such that X belongs to a natural number and X is equal to 3n. This is in the rule form. This is nothing but, if you take n is equal to 1, 2, 3, 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9. So you will get the same element. So this is how we are going to represent the given set multiples of 3 in roster form as well as in the rule form. In the roster form, the elements are 3, 6, 9, 12, and in the rule form, x such that x belongs to a natural number and x is equal to 3n, x is equal to 3n. Or if you want, you can write like this also. This can also be written as x such that x is equal to 3n and where x belongs to natural number. This is also the method. Now, let us come to the second problem. Set of all integers between -3 and +3. Now, let us write the set of all integers between -3 and +3 in roster form. So, let us consider A is equal to the set of all values which lies between -3 and +3 is -2, -1, 0, +1, +2. That's all. So, the values which lies between -3 and +3 are 0, 1, 2, -1 and -2. So, the second form, rule form. So, the rule form, this is nothing but, that is set builder form for this is all the values which lies between -3 and +3 can be written as, so x such that x where -3 less than x less than +3 where x belongs to any integer. So the value of x which lies between -3 and +3 is a representation of -3 +3 in set builder form. Or this can also be written like this: A is equal to x such that x where -3 less than n less than +3 where n belongs to any integer z. This is how we are going to represent. Now let us come to the third problem. What is the third problem? Set of all prime numbers less than 20. Set of all prime numbers. You know, prime numbers means numbers which are not divisible by any other number except one and the same number. So here let us write the set of prime numbers 2. Yes, 2, 3, 5, 7, again 8, 9 is divisible, 10, 11, 13, 14 is not there, 15 is not there, 16, 17 and the last one is 19. So these numbers 2, 3, 5, 7, 11, 13, 17, 9 comes under the set of prime numbers which are less than 20. Okay, this is the representation of prime numbers less than 20 in roster form. This is called the roster form. Now, whereas the set builder form or rule method can be like this. In rule method, the same statement A is equal to x such that x is a prime number, x is a prime number less than 20. That's it. X is a prime number less than 20. This is the statement. So here in roster form the elements are listed and separated by the commas, whereas in rule form or set builder the elements of the set are stated according to a definition or a given statement or a given property. So these are the statements, that is called a rule method, or it is also called as a set builder form. Okay. Now let us come to the next concept. Convert the following sets from roster form to rule form. Now we have to convert this set from roster form to rule form. Now first one, what is A? A is equal to 4, 8, 12. If you observe carefully, these are nothing but the multiples of 4. So this is 4 into 1, 4 into 2, 4 into 3, etc. 4 ones are 4, 4 2s are 8, 4 3s are 12. Therefore, this can be written as the set A is equal to x such that x is equal to 4n. X is equal to 4n for all n belongs to any natural number. Any natural number. That's it. See here what is given? 4, 8, 12 are the elements of the set. They are in the form multiples of 4. So the multiple of 4 statement can be written as A is equal to x such that x is equal to 4n for all n belongs to the natural number. Now let us come to this second problem. E is equal to June and July. If you observe carefully, these are the months which start with J. These June and July. So that is nothing but the months of the year which start from J. That's it. Now how to write the statement for this? The statement can be written as E is equal to x such that x is a month of, x is the month of year, starts from starting from J. That's all. So the name of the month of the year we start from J, June and July. Now for the third problem, what is the third problem? C is equal to A, B, C, D. The set C is equal to A, B, C, D. If you observe carefully, these are nothing but elements of the English alphabet. That's it. So therefore, this can be written as C is equal to X such that X is the first 4 letters of English alphabet. That's it. Here A, B, C, D is nothing but first 4 letters of an English alphabet. This is the statement for the given problem. Come to the next set of problem. Convert the following set from rule to roster form. From rule to the statement is given. We have to construct the set in the roster form. Very simple. X such that X is a letter in the word engineering. So we have to list the letters in this. That's it. So what is the statement? A is equal to X is a letter in the word engineering. Let us take E, then N, G, I. N is already taken, E is already taken, R, then I is already taken, N is taken, G is also taken. That's it. These are the letters of the word engineering in the roster form. That's it. E, N, G, I, R. 5 letters. That's it. Now, next. B is nothing but N such that N square minus 7N plus 12 is equal to 0. A quadratic equation is given. Just find out the roots of this quadratic equation. What is given? N square minus 7N plus 12 is equal to 0. This 12 can be factorized as 3 4s are 12. So this is plus. You can write minus and minus. So N square minus 3N minus 4N plus 12 is equal to 0. You can take N common factor, N minus 3 minus 4 common factor, N minus 3 is equal to 0. The factors are N minus 3 into N minus 4 is equal to 0. Therefore, we can write N is equal to 3 or N is equal to 4. So, therefore, the elements of the set B is equal to 3, 4. That's it. These are the elements. So, from rule to roster form. The elements of the set B is nothing but the roots of this equation n square minus 7n plus 12 are 3, 4. So, if you substitute n is equal to 3 and 4, this equation is equal to 0. That's it. Now, let us come to the next one, types of sets. This is very important. The types of sets. First one is null set, or it is also called as an empty set. Empty means nothing. A set containing no element is called an empty set or null set, and it is denoted as psi or like this. So, a set which does not contain any element is nothing but a null set. Okay. For example, set of all triangles in a plane whose sum is more than 180 degrees is a null set, because sum of 3 angles is 180. Greater than 180 is not possible. So, it is also a null set. Similarly, let us take one more example. The set of all even prime numbers other than 2. 2 is only the even prime number. So, the set of all even prime numbers other than 2 is also an example for a null set. Set of all natural numbers less than 0 is also a null set. So, 0 less than 0. So, set of all natural numbers less than 0 is not possible. It is again an empty set or a null set. So, the set of even numbers less than 2 is an example for a null set, because 2 is only the even natural number and less than 2 is not possible. Prime numbers, even prime numbers. So, the set of all even prime numbers less than 2 is a null set. Second one, set of all natural numbers less than 0 is also a null set. Next, singleton. Single means one. A set containing only one element. A set containing only one element is called as the singleton set, and that is, let us consider an example. If A is equal to x such that x minus 1 is equal to 0. What is x minus 1 is equal to 0? That is nothing but x is equal to 1. So, A is equal to 1. This is an example for a single set. That means, a set containing only one element is called as a singleton set. Now, next, finite and infinite set. Finite set means a set is said to be a finite set if it contains definite number of elements. A set is called a finite set if it contains finite number of elements, definite number of elements. Suppose if A is equal to 1, 2, 3 and then the number of elements in the set A is 3. So, the number of elements is denoted as n of A is equal to 3. Therefore, this is a finite set. A set containing definite number of elements is called a finite set. For example, A, E, I, O, U. How many elements are there here? This contains 5 elements. So, therefore, the number of elements in this set is 5. Therefore, this is a definite set. That is called a finite set. Now, a set which is not finite is called an infinite set. If it contains infinite number of elements, then it is called an infinite set. Let us consider, for example, if A is equal to set of natural numbers, etc. This is an example for an infinite set. 1, 2, 3, 4, etc. This is an infinite set. It does not contain definite number of elements. So, in general, a set containing finite number of elements is called a finite set, whereas if a set containing infinite number of elements, then it is called as an infinite set. Now, the set of all natural numbers is an example for an infinite set of all natural numbers up to what they have not given. So, the set of all natural up to infinity is an infinite set. Set of all the real numbers, that is up to infinity, is also an example for infinite set. Now, let us come to this equal sets. Let us know regarding equal sets. When did you say two sets are equal? Two sets A and B are said to be equal if and only if they have exactly same elements. If the number of elements and the elements are same, then the two sets are said to be equal. So, two sets are said to be equal if and only if they will have the same number of elements and same elements. N of A is equal to N of B. The cardinality are equal. The number of elements in the set is called the cardinality. If the cardinality of both sets are equal and they will have the same elements, then the sets are said to be equal. Now, let us take an example. If A is equal to 138 and B is equal to 831. So, here number of elements in A is 3. Number of elements in B is also 3. Both contains 3 and 3 and the elements are also same 1, 1, 3, 3, 8, 8. But the order is different, right? So, these two sets are said to be equal and it is denoted as A is equal to B. Followed. A and B have the same elements, therefore, A is equal to B. Now, let us take one more example. If A is equal to a set X such that X is a letter in the word FLOW. See, let us consider one more example. X such that X is a letter in the verb FLOW. Another set B is equal to X such that X is a letter in the word WOLF. See, already W is here, then O is also here, L is also there, F, wolf. So, these two will have the same elements and the number of elements are also same. N of A is equal to N of B is equal to 4. So, therefore, these two sets are said to be equal. A is equal to B as A and B have the same elements. Now, suppose if A contains, if a set A contains 1, 2, 3, 4, 5, another set B contains 4, 5, 6, 7, 8. These two sets, the number of elements are same. N of A is equal to N of B is equal to 5. Elements are not same. Just they are equal in size but not equal sets. These two sets are said to be equal in size. The cardinality are equal but they are not equal. They are not equal. See the difference between this and this. Right. Now, let us come to the next one. Equivalent sets. Equivalent set. Two finite sets A and B are said to be equivalent if they have same cardinal number, that is the same number of elements. Just now I have given an example for equivalent set. If the number of elements are same, then they are called as equivalent set, not equal set. So, equivalent, two finite sets A and B are said to be equivalent if they have same cardinal number, that is the same number of elements. Number of elements in both the sets are equal, means then the two sets are said to be equivalent set. That is if N of A is equal to N of B. Let us take an example. A is equal to A, E, I, O, U. B is equal to 1, 2, 3, 4, 5. The number of elements in set A is 5 and the number of elements in set B is also 5. just they are equal in number, but they are not equal. So such type of sets are called as equivalent sets. Okay. Now, another example. Now take another example. If A is equal to 1, 2, 3, another example 3, 4 and 5, then here these two are said to be equivalent set. Number of elements in A is 3 and number of elements in B is also 3. Number of elements are same, but the elements are not same. Therefore, they are equivalent set, not equal sets. Now, two sets A and B are equivalent if and only if the number of elements in A and the number of elements in B are same. Now, let us come to the very important concept that is called the subset. This is very, very important subset. If each and every element of A is an element of B, then A is called the subset of B, or A is contained in B and it is denoted as A is the subset of B. So, if all the elements of A must be the elements of set B, then A is called the subset of B. Let us take an example. If A is equal to 1, 2, and B is equal to another set B is equal to 1, 2, 3, 4, then A is the subset of B, because all the elements of A are the elements of set B. A contains 1, 2, B contains 1, 2. So, therefore, A is the subset of B. So, A is the subset. All the elements of set A are the elements of set B, then A is called the subset of B and it is denoted as A is the subset of B. Now, take one more example. I will take one more example. If A is equal to A, B, then another set B is equal to A, B, C, D, E, then A is the subset of B, because the elements of A are the elements of set B, A and B are the elements of set B, therefore, A is the subset of B. That means, all the elements of A are the elements of set B, therefore, A is the subset of B. Okay. Hope you follow. Subset means the elements of A must be the elements of set B, then it is called a subset. Okay. Now, let us come to a note. If at least one element of A does not belong to the set B, then A is not a subset of B and symbolically it is denoted as A is not the subset of B. Every set A is the subset of itself. Every set is the subset of itself. So, therefore, A is the subset of it. That is, null set is also the subset, every subset. Then, if A is a subset of B and B is a subset of A, then A is equal to B. So, this very important property. Every set is the subset of itself. A is the subset of A and null set is also a subset. And if A is the subset of B and B is the subset of A, then the two sets A and B are said to be equal. So, set of all natural numbers is the subset in set of all whole numbers. So, the set of natural numbers, whole numbers contains whole numbers 0, 1, 2, 3, etc. Whereas the natural numbers contains all counting number. So, therefore, this N is the subset of W. That means, set of natural numbers is the subset of the whole numbers. Okay. Let us take few examples. Now, write all the possible subsets of the following. Let us take this example. This is very, very important. You may expect one question for 3 marks from this. Now, if A is equal to 1, 2, 3, then write down all the possible subsets of this. So, the subset of this is denoted as P of A is equal to, first take 1, then 2, then 3, 1, 2, 3, then 1, 2, 1, 2, then 2, 3, then 1, 3, then the whole set 1, 2, 3 and the null set. These are the subsets. So, the possible subsets of 1, 2, 3 are 1, 2, 3, 1, 2, 2, 3, 1, 3, 1, 2, 3 and the null set. See, how many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets are there. So, in general, if a set A contains n elements, then the number of subsets n of A, number of subsets is denoted as P of A, power set is always equal to 2 to the power of n, that is 2 cube is 8. Just I will explain in the moment. Now, for the time being, the number of subsets here we have 8. Now, let us come to this. So, here according to this, since it contains 2 elements, then the number of subsets which can be formed with this A is equal to B is equal to A comma B is 2 to the power of 5. Sorry, 2 to the power of 2 is 4. Now, write down the subsets of this. B is equal to first A is the subset, then B, then A comma B, then the null set. So, these are the 4 subsets. So, the possible subsets of A and B are, these are the possible subsets. Now, let us come to the general concept, that is superset. Set A and B are 2 non-empty sets such that A is contained in B and A is not equal to B. That is, set A and B are 2 non-empty sets such that the set A contained in B, set A is contained in B and not equal to B, then B is called the superset of A and it is symbolically denoted as B is the superset of A. B is the superset of A. Set of complex number is a superset of set of real numbers. Set of all complex numbers is a superset of set of all real numbers. Now, proper subset. What is a proper subset? A set A is called the proper subset of B if each and every element of A is an element of B. That means, if each and every element of the set A is contained in the set B and A is not equal to B, then that is called as the proper subset. A is called the proper subset of B if each and every element of A is contained in B, then A is called the proper subset and A is not equal to B. So, symbolically the proper subset is denoted as A is the proper subset. That is what we took the example and did it as A is the proper subset of B. Okay. If A is called the proper subset of B, if each and every element of A is an element of B. Say for example, if I take A is equal to 1, 2 and B is equal to 1, 2, 3 and 4, then A is the proper subset of B. All the elements of A must be the elements of set B. Right. Now, let us come to the next concept, power set. Very important concept, this is power set. The set of all subset is called the power set. A set formed by all the subset of A is called as the power set of A and it is denoted as P of A. The set of all subsets of A is called the power set. Now, let us consider for example, if A is equal to A comma B, then all the subsets of A are A, B and a null set. So, therefore, the power set of A is equal to 2 square, that's equal to 4. That is, let us take one more example. If A is equal to 1, 2 and 3, then the power set of this is nothing but set of all subsets of this. So, let us write first 1, then 2, then 3, then 1 comma 2, then 2 comma 3, then 1 comma 3, then 1, 2, 3 and the null set. This is called the power set of set A is equal to 1, 2, 3. Count how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. So, this is nothing but 2 cube is equal to 8. That means, in general, if a set contains n elements, then the power set of that set is given by P of A is always equal to 2 to the power of n. The number of subsets of A is 2 to the power of n. So, here it is 2 square is 4, here it is 2 cube is 8. Now, that is number of subsets n of P of A, number of subsets of P of A, that is power set is always equal to 2 to the power of n, where n is the number of elements of the set A. Suppose if A contains 5, 6, 7, then power set of A is nothing but set of all subsets. So, that is nothing but 5, then 6, then 7, then next element 5 comma 6, then 6 comma 7, then 5 comma 7, then the whole set 5, 6, 7 and the null set. See, 1, 2, 3, 4, 5, 6, 7, 8. This is 2 cube is equal to 8. P of A. So P of A is equal to 8. Suppose, let us take this example. If A has 4 elements, how many elements will P of A will have? So here n is equal to 4. According to the definition, the number of subsets, power set, P of A is always equal to 2 to the power of n, 2 to the power of 4. 2 to the power of 4 means 2 to the 4, 4 to the 8 to the 16. So then this will have 16 subsets. Okay. So if a set has 4 elements, then it will have 16 subsets. So P of A is equal to 2 to the power of n, that's equal to 16. Okay. Now let us come to the next. If A is equal to 2, 3, 4, write all the proper subsets of A. Proper subsets of A. The proper subsets of A are proper subsets of A. Proper subsets of A is equal to, first write down 2, then 3, then 4. 2, 3, 4, then 2, 3, then 3, 4, then 4 and 2, that is 2 and 4, and the null set. So these are called the proper subsets of the given set. A is equal to 2, 3, 4. That's it. Okay. The next concept is universal set. Universal set means set of all the sets, that is union of all the sets. If all the sets under considerations are the subset of a set U, that is called an universal set. If all the sets under consideration are the subsets of a set capital U, is called the universal set. All the sets which comes under this consideration is called the universal set, U denoted as U. Example, for the set of integers Z, the universal set can be the set of real numbers R or the set of complex numbers C. So the set of complex numbers or set of real numbers, use the universal set for the set of all integers, because all integers comes under the set of real numbers or complex numbers. Now the next concept, cardinality of a finite set. As I told, the cardinality of a finite set is nothing but the number of elements of a finite set is called the cardinal number, and it is represented by n of A. N of A is called the number of elements of the set, that is called cardinal number. Let us consider, for example, if A is equal to 1, 2, 3, 4, 5, 6, it contains 6 elements, then the cardinal number of the set A is n of A is equal to 6. Suppose if A contains, A is equal to 1, 2, 3, another set B is equal to 3, 4, 5, 6. Then the cardinality of these two sets are here n of A. N of A contains 3 elements and n of B is equal to 4 elements. That's it. So these are few concepts regarding sets, the types of sets and the power set, and finding the number of elements of the subset. So the important concept is the power set is the set of all subsets denoted as P of A. This is called the power set. Set of all subsets of A is called the power set, and the number of elements of the power set is denoted as n of P of A is always equal to 2 to the power of n. That's it. Okay. These are few concepts regarding the sets. So that's all regarding today's session. Let us meet with the different concept, that is the operations on sets, in the next class. Thank you very much.